All right, welcome students. Welcome to another video tutorial in machine learning. Today we are going over a exercise dealing with inventory and NumPy or numerical Python. This exercise will kind of go through a few things. So as we're learning kind of the building blocks of machine learning and data preparation, we are kind of dealing with, let's say, the data that we feed into a machine learning model using Python and popular data science libraries. Doing this kind of work in a code lab will help us as we work toward finally building a machine learning model and deploying it. All right, so let's get started. Today we are actually using a Colab document, so make sure you have Google Colab open, and we're going to create a new document. I will ask that students submit this assignment on Blackboard right in the submission link, and that will be graded 4 marks. So let's get started here. Okay. All right. So this Colab will demonstrate a few things. One is using NumPy's random seed. So we want reproducibility with random seed so we can have consistent data that we can look at and draw insights from. We're also going to be using NP dot for calculating the dot product. We'll go over the dot product and how that kind of works. But in this example, we are looking at just comparing inventory counts from 1 week to the next. Okay, so dot product again is great for measuring. It's used actually in a wide variety of ways in machine learning, mathematics, and so on. But in this context, we're going to use it to assess any changes in inventory levels. Okay, and we're actually going to use matplotlib as well to visualize those changes. Okay, because part of our job as data scientists or analysts is to communicate those changes to various stakeholders as well. Okay, also we'll be using NumPy's concatenate method to create a new array or matrix, if you will, out of 2 existing vectors. Okay, so let's get started. The first part of this is we're going to import NumPy. All right, so import NumPy as NP, and then the second import is going to be matplotlib, and we're going to use the pyplot library, and this is going to be given an alias of PLT. Okay, so it shows us quite a bit. It's a good cross-section of dealing with NumPy and matplotlib as well. So the first thing we're going to do, and we'll make comments, is we're going to set some boundaries for random quantities. And what this means is we're going to be using random int. So that gives us random integers. And we do have to set boundaries for those random integers. And we also can set the size or the output of those random integers. So that's what we're going to do here. So we're going to set a minimum quantity, and that's going to be equal to 50. Then we're going to set a max quantity, and this will be set to 300. Okay. All right, so we kind of set boundaries for the data. Otherwise, we would have too much data or not enough. Okay. The next part is we're going to instill reproducibility, and how we do that is we're going to use random seed. So NP random seed. And this number that goes inside the seed method is arbitrary. So you can actually put any sort of number in there, or integer, and it'll do the same thing, okay? But as long as you have this line, when you, the rest of your code, when you're using random int, those random integers, or even if you use rand for floats, those items will stay consistent, so they won't change. If you didn't have this line, or say I commented this out, then those values would change every time you run it. Okay, the next part is we're going to generate random quantities for weeks 1 and week 2. Okay, so you can see Colab is already trying to predict what I'm trying to do here, and they're on the right track. Basically, again, this exercise will use the dot product to evaluate inventory levels that change from week to week. But we're going to do this manually because we need to work out our fingers. And we need, again, it's better for memorization again. So we're going to do week 1 quantities is equal to random rand int. And we're going to pass in min quantity, max quantity as the second argument, and then finally size. Our size is going to be 3. So we're just going to keep it basic. We're going to have only 3 inventory counts, okay? And we'll give them labels. So our 3 inventory items are going to be t-shirts and jeans and hats, okay? So that's week 1. But week 2, it's going to be a little bit different. So this is going to be equal to week 1's inventory count, okay? Because again, we're comparing week 1 and week 2, so we want some semblance of similarity. So we're gonna just have a slight difference here. So np random rand int, and we're gonna go -20, 20, and then the size is gonna be exactly the same. So what this is doing essentially is it's week 1, but we have these slight variations here on the random ints, okay? Okay, just some slight variation. Excuse me. All right. Okay, so that explains that. So basically, this is our data. This is synthetically generated. You can see for week 1, we use random int, and then week 2, we also use random int, but we're using week 1 as a baseline. So it's basically week 1's data, but we're introducing with np random int slight variations, so -20 and 20. So we'll see those slight variations in the data, and really it's for the visual too, okay? All right, so the next part is we are giving product names for the labels. So these are product names. If you were to feed this into a machine learning algorithm, you would know that it would be a supervised learning algorithm because we know what the data is. It has column headers, if you will, or labels, and we can, if we're trying to do some classification task or something like that, we can give it labels. Okay. All right. So we're going to create a list, and this is just going to be a categorical list. So we'll go t-shirts, whoops, excuse me, t-shirts, jeans, and hats. Perfect. So we've got a few things done. We've set the boundaries. We've ensured reproducibility in the data. We've created our synthetic data with a slight variation, and now we have a list with our labels for the data when we go to plot that out with matplotlib. Okay, excuse me. All right, so we have the data, but a NumPy is great for creating arrays. So we want to create arrays out of the data. The data will be essentially vectors, so one-dimensional arrays. And so what we're going to do is we're going to go week one array, and we're going to use snake case convention, and we're going to go array week one quantities and array week two quantities. And you can just tab that out because that's exactly what we need. And we can make a comment for each, if you will. So array for week two. So if you print those out, those are going to look like standard arrays, okay? All right, but the next part is we want to be as intuitive as possible. So we want to, let me zoom in a bit. We want to display the data. So we're going to print the properties of the arrays, and we'll do it for week one, and week two is going to be very similar. So we'll go week one quantities, and this is going to be equal to the week one array, essentially. Okay. All right. The next part of this is we're going to actually just use the shape command. So the shape, if you recall, and during our lecture, is just the dimensions of the data. Okay, so it'll give you, if it has rows and columns, it'll give you both the numbers. If it just has a row or rows, if it just has a row, it'll give you the number of items in that row. Okay. And we want to print these out just so we can see the data that we're working with. So the first print statement, we have the string. Don't forget the comma right after the colon here. Sorry, not right after the colon, right after the quotation mark. And we're going to do the exact same thing for week two. So copy that, and we're just going to change the value. So week two array right here. And just make sure those twos turn into ones. All right. The next part is, so we're just kind of looking at the arrays here, and we're calling the shape. So that'll give us how many items are in the array. The next part is we're going to calculate the change in quantities from week 1 to 2. Excuse me. Okay, and what does that look like? Well, we're just getting the difference, okay? So we're going to go quantity change. So this is our variable name, and this is equal to week 2 array. And I'm just going to tab that out. Oh, excuse me. Minus week 1 array, and that's the difference. That's the change. And then finally, we're going to print that out. We're actually going to use an escape character. This is n, so that's new line. So anytime you want to use or print stuff on new lines here, you just use the \n, and you can see there's no space between the \n and change, and then we'll go change in quantities. Okay. All right. Okay, so that's going to give us the difference between week 1 and week 2. And the next part is we are going to display the prices for the products, or actually give the prices for the products. So right now, we just have inventory levels. Okay, we have inventory levels. We converted these to NumPy arrays, so we can work with them. And in machine learning, that's exactly what we do. We take data, we'll convert them to arrays. We might reshape them. We might inspect them. We might clean them or get rid of outliers. But now we're going to create prices. So let's create a new price prices list, and this is going to be, well, sorry, NP array, which is essentially a list or a vector, and we're just going to give arbitrary values for our items. So if you recall again, t-shirts, jeans, and hats. So these will correspond respectively to those items. Okay. All right, and we can make a note here. Okay. So we have the prices, but now we're going to use the dot product. So the dot product, again, is going to be used to assess the changes in inventory levels. And again, when you have two vectors, it's a very simple calculations. You would take the two the first position or index values from each vector, and you would times them together, and you would go along the vector. So index position 1 from 0, you would time that together, and then the last index position in this case, you would times that as well, and you sum all of the products there. So I have an illustration here of two vectors. They both have the same shape, and you can see we start from the 2, we times it by 8, okay, and we plus that by 7 times 2, and then we plus that by 1 times 8, and then we sum all that together and we get a dot product of 38. So now I know if we apply this to our inventory level, it's the exact same calculation, and it gives us one scalar unit or one scalar quantity that we can identify. So if we were to run this calculation again, we can then gauge if any inventory levels have changed. Okay. But what does that look like in the code? So let's have a look at it. So first we're going to calculate inventory value change. So we know the difference in inventory with our difference calculation above, but what is the change in value? So we can use NP's built-in dot method, and the first argument it takes is the quantity change, so our difference, and then the second argument is the prices. Okay, and what we're going to do then is print those the inventory value change out. Okay, and we can just have this print statement. Colab just predicted it, so I just tabbed it out for efficiency there. Okay, so if we actually run this now, okay, and it's looking good, we have comments for all of our lines. Let's run this out, and you can see that we have, to start, we have week 1 quantities. We have the shape for this array, this NumPy array, and you can see it's just X values. So there's 3 items, there's scalar units. And then for week 2 quantities, we also have 3 items as well. So that would be the shape. If this was a 2-dimensional array, it would give us Y values for the rows as well, right? Okay, the change in quantities we have here for each item. And then finally, we do have both the change in quantity and the price calculation. So this is actually the change in value across the board. So we calculated that simply with this NP dot calculation, and I did show you an illustration in the video of the dot calculation, which is pretty simple, but we can include prices. So now we can draw insights in real time on inventory levels, and this could be used in demand forecasting. This could be used in just real-time analysis. Just-in-time logistics is sort of the modern way warehousing and logistics is done, and that does rely a lot on real-time data. Okay. All right. So the next part here, I'm just going to zoom in, is we're going to concatenate the data into a two-dimensional array. Okay, or you could view it as even, tabular data with rows and columns. So what we can do is we're going to create a variable called inventory data, and this is equal to np concatenate. Okay, and we actually had an example of this in our class. And basically what it does, and there's two sets of these parentheses, so be careful, is it just takes as arguments two different arrays. That's it. And concatenation, again, is just you're attaching something to the end. So we're going to go week 1 array. And for the second argument, we're going to go week 2 array. Perfect. So we have now concatenated those arrays into a single array. And why would you want to do that? Well, if you were to feed it into a machine learning model, you can combine all your data into one, two-dimensional or more, even a matrix or a tensor. And this is, again, all part of data preparation before we're even engaging the model or the algorithm. Okay, so this next step here is we're going to print on a new line the inventory data. Okay. There we go. Okay. We're also going to print the shape of inventory data just to give us some insight, and we just call shape on it through dot notation. And just for good measure, we're also going to call ndim. So if you recall from our instruction, ndim gives us the number of dimensions. And again, we do this to get familiar with the methods in NumPy, and there's many of them that will assist us later in our machine learning tasks. Okay. The final part of this, and this is important, is visualization. So we're going to be plotting the data, and we're going to use our plot alias. And the first part of this plot method, and it's always plot to begin with, is the data. So we're going to run in the products. And if you can see here, the products are the labels. Oh, I lost my cursor. Let me get back. I don't know why the cursor is invisible, but all right. The first part of this is labels, rather, and then we're going to pass in the week 1 array. We have a third argument just indicating the marker. So what does the marker look like? We just use an O. Okay, that is an O. We're going to give it labels in line. So week 1 for the data, and we can also affect the color of the line. So this is a line graph. Okay, and the great thing is once you do the first line, you can essentially copy that and paste it and just change the values. So there's 2 spots. We're going to change, or actually 3, because we need to change the color. And we have orange. Perfect. Okay, so that is good for plotting the data, but we also have to add labels to both axes and the title of the chart. So what does that look like? Well, we have an X label, and that is indeed products. So Google Colab is very predictive. We have a Y label, and that corresponds to quantities of those products rather. We're going to give it a title of inventory levels, and we'll go week 1 versus week 2. And not finally, we're going to give it a legend. So this is just, once you implement that, the legend is there, and the legend will just indicate the colors blue and orange for each line. Okay. All right, so that is finished for the setup. Finally, we just have to show the plot. And what does that look like? Well, we'll go plot grid, and that's optional. It'll just show you a grid corresponding to a standard grid pattern. And finally, we always with matplotlib, we are showing it. So there's kind of a standard way to implement matplotlib. We have this plot where we feed in the data, the marker options, the labels, and then finally the color. And you're going to have two plots, right? One for the x1, sorry, not two plots, but you're going to have plots according to the data, okay? In this case, we have two sets of data, week 1 and 2, and of course you can have variations of that. The next section here is we're applying labels to the X and Y axes. We have the chart title and then the legend, and then we're calling grid and show, okay? All right, and that is it. So just make sure that you have everything here outlined, and you may have to pause the video, but we're going to run this now. Excuse me. And what you can see is in addition to our change in quantities and our week 1 and week 2 quantities and the shapes, and the value change, we now have inventory data in a two-dimensional array, and we know it's two-dimensional because we have brackets, excuse me, encapsulating two vectors. We have the shape of the data, so 2 by 3, 2 rows by 3 columns. We have number of dimensions, so that's our ndim. And then finally, we have the matplotlib visualization giving us the inventory changes, okay, from week 1 to 2. All right, so I hope you enjoyed, excuse me, this code lab. Again, this could be applied to demand forecasting. We can also use it to prepare the data, any sort of data, before we feed it into a model. And it's a good cross-section of NumPy's built-in methods and just ways of doing things, as well as implementing, excuse me, matplotlib. Excuse me. So I hope you enjoyed. Thank you very much. And students, make sure you submit, you add this to a file, or you save it to a file and then submit it on Blackboard when you're done. Okay, thank you very much, and we'll see you again.